So good morning, everybody. Now we've got to overcome the minor technical details. So first of all, I would just like to thank Sanjay and the Geospatial media team for again putting on a fantastic event here. And it's an honor and a pleasure for Trimble to be able to participate in these types of events where we get the opportunity to explain where we see the geospatial capabilities in the world going and how they can apply to different countries around the world. So what I'd like to do this morning is just spend the first couple of slides talking about some of the trends that we see evolving within the geospatial capabilities, and then look at how those are applied in real life in various situations. So what we're really seeing is that converging forces are placing geospatial capabilities at the center of an evolving ecosystem. So if we look around what is happening in the world today and how geospatial information is being utilized in multiple industries, we're seeing really we have the advancements in the technology, whether that is in terms of sensor integration, it's the emergence of the smart devices and how they can be used from a crowdsourcing perspective to capture information, or the evolution coming out of remote sensing, mobile mapping, etc. So multiple technology advances are making the capture of geospatial information far easier than it has been in the past. The second one, and to me this is one of the more critical ones, is how that is then applied to solve a particular problem. It's great being able to collect these billions and billions of points of data, but how is that going to be applied to solve a specific problem, whether that be in the agriculture industry, in the construction industry, in the transport and logistics industry, or maybe in developing a smart city, water management, electric management, etc. So that's a critical piece we have to think about, is how do you extract the appropriate data and apply it to solve a specific problem. The third one, I think, affects the roles of individuals play in their specific industries. So if you look at the evolving role of the surveyor or the geospatial professional, their roles are changing dramatically, and it's critical that as the capabilities evolve, that we learn to change our roles to keep up to date with the capabilities and the amount of data and the requirements of the industry. The fourth one is the economics around the utilization of geospatial data, whether that's on a construction site in terms of the reduction of rework, the reduction of material usage, whether it's on the farm, again, for the reduction in seeds required in plantation because we're using precise capabilities to plant the seed, or the reduction in the use of pesticides or fertilizers. There are significant economic benefits that have been driven out of the use of geospatial information. And the last one is the societal forces, and this can relate to environmental pressures, the drive to go green, again looking at how we can reduce the CO2 emissions by using geospatial information. As we talk about in agriculture, how we reduce the use of pesticides or fertilizers, again, helping the world become a greener place. So looking at this ecosystem, then we start to look at some of the characteristics that are really driving this change. So one is looking around the paradigm shift that has taken place out in the industry. It's moving away from that point-centric collection into this mass data collection. But again, the important thing around that is how do you extract the information you need to solve that particular problem? Looking at the opportunities, or with the low investment required in some areas, what are those adjacent opportunities that now exist for the utilization of geospatial information, and how that can interact both from an industry perspective, but maybe within the citizens within a local community as well. There's a couple of videos towards the end will demonstrate how that has been applied in one country in the world. The third one is looking at emerging economies and how emerging economies can take advantage of the capabilities that exist, but also in some ways are able to leapfrog the way maybe the Western world is developed by adopting the latest technologies and not having to go through the path that other parts of the world have gone through. And we're beginning to see that as parts of the world start to implement maybe their first land management or cadastral system. They haven't got to go through all the steps that have been followed in the past. They can go and adopt the latest information or latest technology immediately and leapfrog the way the rest of the world has developed their land management systems. And the last one really is a technology as enabler. It's the integration of the data collection capabilities, the software capabilities that now exist, and also the connectivity to provide a very, very rich solution set that can be utilized by multiple parties or stakeholders who require geospatial information as part of their overall solution. So we start to look now at what's happening from a spatial data evolution. I won't go through all the points here, but I think a couple of the key ones we're seeing. So the migration really from everything being processed in the office to now a far greater ability to process information out in the field. So you can get far closer to the point of where the user's using it to process that data. Crowdsourcing. Data's coming from multiple sources, including the citizen. We talked this morning about how many 900 million, I think, mobile phones are now being used in India. That's another way of utilizing and bringing data into a central repository to then be used to help effective decision making. Getting down to access. So access before really was proprietary. You had to have the capabilities and the skills to get access to the data. Now in many ways, a lot of the information is free and ubiquitous for everybody to use. The data integrity is a key one because whilst we're collecting all this data, somebody still needs to provide that validation that that data is accurate depending on the purpose it's being used for. If you're using sub-meter data, it has one level of validation or authentication that's required. But if you're using centimeter data for construction purposes, it has a very different set of authentication and validation that needs to be implemented. So again, it's understanding the need and then addressing the process to meet the need. So if we migrate on now and start looking at the evolution of the cloud and how the cloud is, again, helping the utilization and the adoption of geospatial information. And for me, the critical piece here is actually starting on the left-hand side of this slide, is understanding the problem or the challenge you're trying to solve for your customer or for the local government. What are we really trying to do? What do we want to do with the information? And then you backwards integrate this to the source of the various data sources you can utilize. And then how do you bring that all together in a cloud environment to extract the information that you need? And what we're seeing now is that the data can come from multiple sources. It hasn't got to come from a specific sensor that's branded to a particular company. It can come from multiple sources, but the critical piece is how do you bring all that information together, and then how do you extract the piece that's required to solve the problem, and then build that application so the end user at the end of the day is only dealing with the information they need to deal with to solve their problem. They don't really need to know what happens in the background as long as they know that data is authenticated, is validated, and it's working to solving their problem. And you can see this goes across multiple industries. It can be construction, agriculture, local government, transport and logistics, oil and gas, railways, etc. Numerous industries are now utilizing geospatial information in this way. The other aspect that has changed dramatically over the last 3 to 5 years is really that ability to collect billions of points in an hour rather than maybe only a few hundred points in an hour. That gives its obvious challenges, but this can be done both in the outside world but also indoors. It doesn't necessarily have to be on a vehicle driving along a street or put on a high rail on a railway line. It can be now done indoors to take a 3D model of a building like this, or to walk through an office facility and take that 3D model. But really what it effectively means is the technology exists to map the world in 3D to centimeter level. And at the session we had last week that Sanjay ran, everybody was talking about this 3D GIS, or this geospatial model. And the world is migrating down this path over time, that we will eventually have a full geospatial 3D model of the world. Yes, it's going to take a while to get there, but that's the vision of where we are going to end up. So what I'd like to do now is just show a couple of examples of how this technology is being applied in real life through a couple of videos. So the first one is just a survey and a mapping consultant in America using a mobile mapping device. But as you look at here, this is the real data that came out of the device through one drive-through, but you can see the level of detail to the cables coming off the telegraph poles. So if you're into asset management, you're looking at managing the tree overhang, etc. You have enough data in that run to start to apply that to respective jobs. And the other great thing about using these tools, here's a second one used on a construction project, is you can utilize this data multiple times. It doesn't have to be used once. It can be used for multiple events. Here you may want it for the construction process. Somebody else may want it for the asset management, for the road signs on the side of the road or the street lights. There's some billboards on the side as well. So it gives a huge amount of rich data that can be used multiple times by multiple end users at the end of the day. The other great thing with these sort of devices for countries that have a high degree of rail networks, again, it can be put onto a high car on a rail network and taken along the rail network. So again, you can do the asset management for the inventory along the rail, you can do the tree overhangs, etc., and again, get a huge amount of rich data. So the other one we like to talk about is how, utilizing the cloud environment, you're able to connect a whole variety of stakeholders who are involved in the geospatial space, but also in multiple industries. And if you take this image here, you can think of a number of industries where this could be relevant. So if you think about maybe a local government organization, you can have citizens who could be utilizing their mobile phones to collect data to send into, whether it's a streetlight maintenance company, it's for potholes on the street, it's for other issues that they're seeing in their local community, comes into a central database. From that database, information can be sent out to the field workers to go and fix the problem if it's a pothole or a street light. On the other side, on the construction site, you can have intelligent machines that are feeding data back as they're completing the work of exactly what's been done from an earthworks perspective, feeding back into the central office that the site manager can see exactly what's happened, who's done what, where, and when. Are they on schedule? Are they behind schedule? Do we need to slow down the supply of raw materials, whether it's concrete because we're behind schedule, etc.? So you start to build this management infrastructure around the site in the construction case or in terms of the local community. All the same, exactly the same can be applied on the farm, where you can have this connected farm concept where information's coming from the machines that are out in the fields, coming into a central hub, and the farm management can start to make decisions about when the workflow they need to go through over the next few hours. So a significant way of connecting the various stakeholders who are utilizing that geospatial information. So the next couple of videos were taken in, this is actually in Denmark. So what they're doing here, this is a way of the local community being able to track when the snow plows that are clearing their pavements or sidewalks are going up their street. So again, they've got a very simple smart device on the snowplow. These are small snowplows, not the big ones clearing the roads. But you can, as a citizen, you can log on to see when your sidewalk or pavement is being cleared. And again, this information is going backwards and forwards between the citizen and the city to make it happen. Very simple device. There's no great expertise written into this. It's a simple script that applies onto the smart device. This one finishes in a second. And the second one here is actually a fascinating one that they developed. So this other city in Denmark wanted to see the traffic patterns for their teenage kids going to school. Now, it's pretty difficult to get any teenager to engage in anything you'd like to do from a local government perspective. What they did is they asked them to download an app onto their smartphone and just switch it on in the morning so they could track both the route they were taking to school, but also the type of transportation they were using, whether using buses, trams, bikes, or cars. And again, they could start to track this to understand exactly how these teenagers were getting to and from school. And to me, it's just this fantastic example of how you can engage with the local community and probably get a group of individuals who you would never have been able to engage in this sort of process before, engaged in helping you to solve a problem by utilizing the latest capabilities that exist. So we said earlier, geospatial information is now at the heart of multiple industries. Here's a sample of them going across agriculture, construction, transportation, electric and water utilities, environmental, oil and gas, but also now we're starting to see it to come into intelligent transportation. A lot of people are talking about the autonomous vehicle, whether that exists on a farm, on a construction site, or a car driving along the road. So I think we're going to see that continued evolution and integration of geospatial information into multiple industries in the future. Now, from an individual who's been a surveyor or is a surveyor or a geospatial expert, really the role of the individual is changing as well. And this is something that I think is critical to support the success of the adoption of geospatial information, in that the individuals now involved in as geospatial experts or surveyors really are migrating from data collection to data management. They've got to really look to establish the context, manage the complexity that exists around the data, and I would argue that from a geospatial perspective, complexity is our friend, not our enemy, in the way that it's applied into industry. Various industries are going to need the skill sets that we provide to ensure that the integration of the geospatial capabilities into their workflow is as effective as it can possibly be. And that is where the true value exists within the survey and geospatial community moving forward. Then just to wrap up the last couple of slides, just some vision things on where we could be going in the future, of actually walking out using some sort of smart devices as glasses, etc., where you can actually see the plans in your line of vision rather than having to look at 2D plans on a piece of paper. Getting down into augmented reality, standing over a street corner, being able to hold your smart device and get an image of exactly what's beneath that junction in terms of the utilities that exist, the depth of the utilities, the size of the pipe, etc. Again, these aren't necessarily there or there in very few places today, but if you think of that 3D geospatial model of the future, these are the sort of capabilities that are going to exist. And the last one is looking at smart devices that actually, or the wearable devices for individuals. So these can be used for site worker safety on a construction site. It can be used for tracking individuals working on a particular vertical building construction site where maybe you're in a high security area, you want to know exactly who is where at what point in time, and do they have the appropriate skills to be on the floor that they're working on. And again, by putting tags on individuals, you can start to tag exactly where they are, and you know who's entered the building during the day, who's exited the site at the end of the day as well. And you can build that around all their tools at the same time. So these smart wearable devices are going to be another trend that starts to come in the coming years. So I hope that has given you an oversight on some of the technologies and the evolution we're seeing in the geospatial environment, and some thoughts and ideas on how they can be applied both from an industry perspective but also from a government perspective. So I hope you enjoyed the forum, and thank you very much.